Assalamualaikum warahmatullahi wabarakatuh to Madam Rashida. Our title for this presentation is the relationship between the percentage of body fat and grip force. Before our presentation, I would like to introduce our group members. My name is Muhammad Daniel Sofa bin Sabri, and another two more members of our group are Muhammad Iman bin Nur Azlan and Ahmad Shahmi bin Abu Zahir.
The importance of analyzing the relationship between body fat and grip force lies on the potential to inform the individual well-being and broader public health strategies. By investigating the relationship, we can gain insights into the physical consequences of excess body fat and its fundamental to the daily life. Grip force. So therefore, body fat is the independent variable and grip force would be the dependent variable. We will using three mathematical models to find the best fit curve for the data, which are linear model, quadratic model and cubic model.
Okay, let's go to the implementation of each model. Our x variable is body fat in terms of percentage, and our y variable is grip force. We're using three mathematical models to find the best fit curve for this data, which is linear model, quadratic model, and cubic model. So we start with linear model first. The equation of linear model is y equals to a plus bx. The 20 data for our group, we substitute x and y into the linear equation. After that, we can set up the dimension for m with dimension of 20 by 2 matrix and for y with dimension of 20 by 1 matrix. First, we find the m transpose multiply with m and find the determinant. And our value for determinant is 22227.16. So the value is not equal to 0. Hence, m transpose multiply with m inverse is as is. Next, we find m transpose multiply with y, and after we get the value, we substitute the value into equation, which is m transpose m inverse multiply with m transpose multiply with y. So we get the value of A, which is 58.7551, and B, negative 0.8738. Hence, our linear equation is y equals to 58.7551 minus with 0.8738x. For error vector equation is E equals to y minus with m multiplied with the answer of the list equation solution, which is A and B. Our answer for magnitude of error vector is 45.2389. We can see two graph for linear model. So for first graph is graph of best fit curve against the observed data for linear model. Second graph is graph of the error vector against x value for linear model.
As quadratic model, the model would be in terms of y equal to a plus bx plus cx squared. So the 20 times 3 vector would be our a plus bx plus cx squared, and 20 times 1 vector would be our y. So the 20 times 3 vector would be we will be labeled as m. So to find the normal equation, we will by using the equation of m transpose m. So as before, we will use 20 times 3 transpose with the 20 times 3 vector. We will get the answer of 3 times 3 vector of the m transpose m. To check whether the m transpose m inverse is exists or not, we will find the determinant. So if the determinant is not equal to 0, hence the m transpose m inverse is exists, and next we will find the m transpose m inverse. We'll find the matrix m transpose y. So we will using the matrix transpose we times with the y vector. We'll get the value of 3 times 1 vector for the m transpose y. So to find the v, we will use the formula of m transpose m inverse we times with M transpose Y, and hence we will get the 3 times 1 vector, which is equivalent to ABC, and also the meaning of ax plus bx plus cx square. Hence, the linear model for the quadratic model is y equal to 91.7487 minus 3.607x plus 0.06479. Sorry, because there is an error in terms of linear equation, because for the 3 times 1 vector on the third row is plus, not negative. As for the error vector, we will use the formula of E equal to y minus mv, and hence we will get 20 times 1 vector, and for the magnitude, we will get the value of 18.1123. This is the graph for the quadratic model. So the graph of best fit curve against observed data for quadratic model, we will see the graph would shape like the curve shape, and this is the graph of error vector against x value for quadratic model.
Next, let's move on to the last types of model, which is the cubic model. From the data, we generate a system of cubic equation with the matrix representation as been shown in the picture. Matrix M and matrix Y. The first column of matrix M represents the value of 1. The second column represents the value of x, third column represents the value of x squared, and the last column represents the value of x cubed. While for the matrix Y, represent the value of y.
Next, we need to find the value of matrix M transpose M, and we will get the 4 by 4 matrix of M transpose M. After we find the value of matrix M transpose M, we need to calculate the determinant of the matrix, and we will get value of 5.7863 times 10 to the power of 15, which is not equal to 0. Hence, we may conclude that our M transpose M's inverse is exists. Then we need to find our matrix of M transpose M's exists, and we will get the 4 by 4 matrix as shown in the picture. Next, we need to find the matrix of M transpose times Y. And after we generate, we will get the matrix of 1 over 4 matrix of M transpose Y.
To find the normal equation, we need to find the value of A, B, C, and D by multiply the matrix of M transpose M inverse and M transpose Y, and we will get the value of A, B, C, and D. Next, we need to substitute it into the normal equation, and we will get the normal equation equals to y equals to 70.5439 minus 0.6335x minus 0.0941x squared plus 0.0023x cubed. Next, to find the error vector matrix, we use the formula of y minus mv, and we will get the answer as shown in below. And next, we need to find the magnitude of the error vector, and we will get the answer is 41.6076. So this is the two graph that we will get from the previous answer. The first graph is about the graph of best fit curve against observed data for cubic model. And the second one is a graph of the error vector against x value for cubic model.
As conclusion, we will compare the error vector for the three model, and from the comparison, we will get the best fit curves model would be cubic model, as the value of 41.0676 is the least error vector between the three model observed.